Okay, so the talk will be held by Eyad Sibai. No need to Spark when you can Dask. And there will be a talk which is guided by tests, what your unit test can tell by Joachim in the second room. If you are interested, you can attend that session. Yeah, good luck.
Hello, everyone. Thank you all for being here. I'll start by talking a little bit about myself. I hold a master's degree in artificial intelligence. And after finishing my master's degree, I started working in a company called Saudi Aramco, the largest oil company in the world. It was a pretty secure job. And then after that, I wanted to get more challenging job. So I moved to Sweden, started working for a company called Campania in the online marketing industry. And then after that, because of my risk appetite, Icetel decided to hire me in the risk department as a risk engineer. And because of my daily work involves in doing some data analysis, building machine learning models, and Python is really rich of many packages, many tools when it comes to that. You have, scikit-learn, stats models. I mean, NumPy. Who knows what NumPy is? Okay, great. And there is one fantastic, actually, package that's called, pandas. Who knows what pandas is? Who loves pandas? Fantastic. I love pandas. Pandas is really this tabular data structure way where you can do things in memory. You load your CSV file or your data and do a lot of data manipulation. Even at Icetel, we have a Slack channel called Pandas Lovers in the internal of the company where we discuss questions and issues with pandas. But here the problems comes, right? I mean, pandas is fantastic when you're working with data that can fit into memory. But what if your data does not fit into memory? These days, you can see many frameworks that can solve that problem. Many people would say, you know what? The obvious answer to this is Spark. Spark coming very famous. Everyone is talking about Spark, Spark, Spark. You should Spark. But do you really need have to Spark? Who knows what Spark is? Okay, for those who doesn't know about Spark, Spark is a general purpose distributed computing framework. And what that means is you are having, I'm gonna try to simplify it for people who doesn't know about Spark. You have your data in a distributed file system or somewhere where it's kind of have shared access between many workers. And there is a master or a driver where would ask each worker to do a certain job. Spark has an API in Scala, Java, Python, R. But today, my talk is not about really Spark. My talk is about another framework that I think it's great. So the framework actually called Dask, but what's Dask? Dask is a flexible parallel computing analytics library is a flexible parallel computing library for analytics. But again, what does that mean? Using task scheduling and blocked algorithms. So what do I mean by that? To explain it further, I would like to explain first what do I mean by blocked algorithms. Here we go. So blocked algorithms, or blocked algorithm, is that your algorithm does not really necessarily work by having all data into memory. But it can work by dividing your data into chunks, and you do some process or some algorithm on each chunk, and then at the end you can reduce the results together. So here we see one example, actually. So you have one-dimensional array. Sorry, this is a mistake actually, so it's not really a list, but a one-dimensional array. Yeah, so I'm having one-dimensional array, and I want to calculate the mean of that array. That array cannot fit into memory. So what I'm doing here is that I'm looping over the file, reading a chunk at a time, 1 million elements at a time, and I'm appending the sum for this 1 million element, and I'm appending the counts. And at the end of the loop, I'm gonna just divide the sum of the sums over the sum of the counts. And then I'm gonna get the mean. This is very simple, basic example. Again, but we can see that something interesting here is that this loop can really easily be parallelized, right? I mean, I'm reading each chunk, and there is not really any problem by running it in parallel, by having all chunks calculating the sum of each chunk and the count at the same time, and then sum the sums and sum the counts. But before explaining more what Dask is, I would like to talk about what differentiates Dask from others. Why Dask? Then after that, I will get back to the Dask ecosystem. First of all, it's native, which means it's pip installable. You just write pip install Dask, and you will have it in your machine. There are no dependencies, nothing really. Well, there are Python dependencies, but nothing really out of the Python ecosystem. It's very familiar. Dask comes with some collections, and these collections have very, very, very similar APIs to NumPy and Pandas. So as we can see here on the left side, I'm reading a file in Pandas, grouping by the user ID, and then calculating the mean. On the right side, I'm almost having the same code. I'm reading more than one file at a time and doing the same thing. Except that at the end, I have to call that compute. And the same thing on the left side where I have the NumPy code, and on the right side where I have the Dask array. As we can see, it's really familiar. I don't have to learn a new API. I don't have to learn a new thing. I can just import Dask and use it right away. It's flexible. Compared to other frameworks, you can really define very complex algorithms. You can really define complex task workflow. And we will see that. It scales. It can run really from one laptop with a single processor with very limited memory to hundreds of nodes. It's responsive. It's designed with interactive computing into mind. It's you can start IPython notebook or IPython, and you can interact with it very easily. So let's talk about Dask ecosystem. So Dask contains the three main components, I would say. Collections, we have Dask collections, and we have Dask schedulers, and we have the Dask graph. But what's really the Dask itself, it's just a graph. It's a graph of tasks that, you are connecting in that graph the dependencies. But actually, that graph is being represented by a Python dictionary. So you have a Python dictionary where you have the tasks, the functions that you want to run, and what are their inputs, what are their dependencies. And we will see that into more details. For people who works in the machine learning, sorry, might be, it seems it's slow. Yeah, this is very small. I'm gonna skip it. But this is a graph of doing cross-validation with scikit-learn and Dask. And as we can see, we see many, it's not really obvious. I'll try to see the next one. Well, yeah, this is a little bit more obvious. So this is doing grid search cross-validation. And as we can see, we see many arrows going from the left side to the right side, and so on. So components are being reused. But again, this is not clear yet. I'm going to now try to explain more. Dask collections. So we talked about that there are Dask collections. Dask comes with three main collections. Number one is Dask arrays, where we said it's very, very similar to NumPy arrays. Here we have an example where I am creating a random array of random numbers, and but as we can see, just for simplicity, I am putting the size to 10,000 by 10,000 and the chunks to 5,000 by 5,000, and then I can calculate the mean over one of the axes. What's happening when I'm creating the random array is that the array is not really being created. What's happening is that I am creating a dictionary, saying in that dictionary that I want to have, I'm defining here the chunks to 5,000 by 5,000, which means I'm going to have that large array divided by 4 chunks. So this is well defined in my dictionary. And after that, yeah, that's it for in the dictionary. And after that, I'm going to calculate the mean. So here we can see, you can visualize the plan, your task graph, before even running the graph. And as we can see, first I'm going to apply the randomness in each for each chunk. And then I'm going to calculate the mean for each. And then I'm going to aggregate them since I said that the axis equals 1. So this is why I am having two together. And after that, actually, you can really calculate, write that compute. And you will get at the end an array of two numbers, which is the mean per axis. Again, so this is another example where I am calculating the mean over all of them together. Sorry here, so the circles actually are functions or tasks. The rectangles are the data that's going to be in memory, that's going to be released or reserved. As we can see at the end, we might have 4 rectangles, right? And here might have some issues sometimes if the system is waiting for all to be there, all the 4 rectangles and they don't fit into memory, Dask really can solve that problem by spilling to disk, which is bad, but still it's a solution. And I think they are trying to improve the scheduler more to solve that problem. This is another example where I did more, as we can see, more sophisticated things. So I calculated the transpose of that array, added it to the original array, then calculate the mean, and then visualize. And as we can see here, we have this fantastic bar, progress bar, when you are calculating that compute. You can see really the bar, you can see what's going on, how much of the task has been done. Dask data frames. Also here, another example that it's super similar to really pandas. You can do that merge, you can do row selection, you can do arithmetic computations, you can do group by, apply, everything. Yeah. And there is also one more thing that's called Dask bag. Who knows about a package in Python called tools that ends with a Z? Okay. Yeah, so this Dask bag is meant, let's say your problem does not fit to be into an array. Your problem does not fit into be into a data frames. Then you have this solution, which is you can really read. This might work really well for text files, for JSONs, for lists. And this is what Dask bag is. And the Dask bag API is very similar to tools for people who uses tools, which is like this concatenation, the frequency, and top K. And actually, this, since we are talking about data or big data, you can't really make a talk without talking about the word count example. And this is a word count example. So I am splitting for each word in each line, and then concatenating each line together, similar as doing grouping by for all. I forgot actually what's in Spark. And then you are calculating the frequency per word, and then I'm getting the top 10 ones. Okay, so there is one more thing here. I don't want to use any of the collections. But I still want to use Dask. I have some code that I want to parallelize. I have some code that I want to solve this out-of-core problem. And what I mean by out-of-core means does not fit into memory. It's different than multi-core. Multi-core means I want to parallelize or utilize more cores of my machine. You have here your functions to do some processing on some data. You want to load data, clean it, analyze, store. And what you do, actually, you create this dictionary that I told you about, which is a tuple, a dictionary of key and a tuple, where the key is the definition or the name of the task, and the tuple is the function and its input. And its input could be either, of course, text, or it could be another task name if the name is there. And then at the end, I am calling this multiprocessing scheduler to do the schedule. And the one on the left is actually is represented here, as we can see by this graph, task graph. But this is nice, but still, I mean, there's here some issue. I mean, I am having here 3 files, right? What if I have 10 files? What if I have 20 files? I mean, defining this is not super convenient. Still, you can do, of course, you can do a loop by creating your Dask array in a nice way, by looping for each file and creating that. But there might be a better way to do it. And here comes what they have recently. They called it, I think, imperative before, and now they call it Dask delayed. So what you do is that you use a decorator, which is called delayed, over each of these functions. And instead, you can define really your workflow or your task graph in this way instead. So we talked about the Dask collections, but I would like to talk also about their schedulers, the Dask schedulers. But again, before talking about schedulers and concurrency, we have one main issue really in Python. Who knows what GIL is? Okay, so GIL stands for Global Interpreter Lock. And it means you cannot have 2 Python threads accessing the Python objects, which means you cannot really have parallel code running. You cannot have 2 threads running at the same time. And why did they really have the GIL in the first place? They said, you know what, we need to let people use C and Fortran code that's non-thread safe. And there are 2 solutions to solve that problem. The first solution is to use multiprocessing, which means instead of creating threads, I'm going to create processes. Well, that solution has some problems. Number 1, it's expensive. Number 2, you might have issues with serializing your code, because you need to serialize it to create more processes. And also, you might have a problem with shared memory. It's not easy to be done. The other solution to that problem is to release the GIL. And we have been people who works with NumPy they might know that NumPy released the GEL, which means that NumPy is letting code runs on multiple threads. That means if you run your code on the multiple threads, it will work. It will utilize that. Pandas is trying to do that. Also, they have released the GEL for the group by function. They have released the GEL for the value counts. And I think there are many coming. There is this fantastic also package that's called, I think, scikit-ll. They made it over a weekend for all their project. And this is also something nice. I mean, you see all Python community is trying to move forward with that, trying to release the GEL. So here we talk about then the Dask schedulers. Dask comes with 4 schedulers, or to be more precise, with 3 schedulers. The Dask is threaded scheduler, which means running in a multiple thread, which is the default for the Dask arrays and the Dask data frames. And in which means in the Dask array, you will have you will really gain a lot of performance by using that scheduler. In Pandas, you might not gain much performance, but you will solve the out-of-core problem, which means if you have data that does not fit into memory. The Dask multiprocessing is the default scheduler for the Dask bag. And there is also the other scheduler that's called from the Dask async, which is the synchronous scheduler. And this one you would use to do debugging. And the 4th scheduler is the distributed, which is a separate package that you can install. And this one to run Dask over multiple nodes, like hundreds of nodes. But you can, of course, I said what is the default schedulers for each collection, but you can even override that. You can change that for each graph if you want. And to do that, you can set it globally, or even you can change it and the get argument for the compute. So you have the power over that. So for example, if you are using the Dask data frame, you might want to switch to multiprocessing. If you want to do some parallelization, you might gain, you might not, it depends, performance. Depends on your code, of course. One interesting thing here also, Dask comes with diagnostic package or module, which has the resource profiler, cache profiler, so you can really see what's happening, what happened to your workers, what happened to your tasks, which one ran, how much memory has been consumed. So you can really analyze the whole process that's happened, which is, I think it's fantastic. But yeah, so these are some of the output of Dask. So you can really check the CPU versus memory, you can check versus time, you can check the cache size, and you can even check how much workload each worker had. And if you use the distributed scheduler, it comes with this fantastic server using bouquet plots, where you can see things running in real time and what's happening to the things in real time. Okay, so we come to the interesting part for some people who wants to know the difference between Dask and Spark. So I have been working with the Spark for a while. And from my experience so far, I could tell that Spark is not really meant to run on a single node. I have been asking around people, how do you use Spark? How much do you use of Spark? They say, you know what, I'm having this machine with a lot of memory, and I'm running Spark on it. It's single node, it's working perfectly. but then why it's working perfectly? Because he's using this fantastic parquet format that's not available in Python, maybe. When you check the Spark documentation, it says, you know what, we support standalone mode for testing purposes. And it's mentioned it twice, and I haven't seen somewhere in their documentation where it says, you know what, you can run this in a standalone mode because this is one of the use cases that we are thinking of. Dask, on the other hand, they started thinking about only running on a laptop or a single node or even a single process on one node. And after that, they said, you know what, we can make this working for a distributed system. And then they made the distributed scheduler. Dask, pip installable, pip install Dask, and I have everything for me. I don't need to worry about anything. Spark, on the other hand, you need install the JVM, configure XYZ parameters, put this in the environment variable. Okay, this one is not working. Rerun. Something is running today. Tomorrow might not run. Something happened. And why is this? Because seriously, if you want to run Spark in production, and you want to, you need a configuration engineer, or you need to use something like Google Dataproc or something as a service. I mean, it's really a hassle. I have some data on my laptop, and I want to analyze it. I want to do that very fast. Yeah. So I don't want to talk more about this. Dask is pure Python implementation. Spark. So here, let me talk about a little bit about PySpark. PySpark have a nice API, easy, I agree. But, and then they created this POI Spark data frames, which is actually, when you are using PySpark with the data frame, you are not holding your data at the Python process, but you are having it in the JVM. And what you are trying to do is that you are, when you are calling functions, you are sending the plan to the JVM to run your code. But you are very limited to the code you are very limited to the functions of PySpark. I have something in my data frame, I need to create this custom function. Okay. Once you create this custom function in Python that you want to run over the Spark data frames, you will have a problem of extra serialization. Because what will happen, actually, the JVM will hold an RDD of a pickled object of Python. And the data will be serialized back and forth between Python and the JVM, which is very expensive. And when I heard this, one of the talks in talking about PySpark and how to improve PySpark and how to make it faster. And the suggestion that they came up with, go write your function in Scala and write an interface to it in Python and go use it in Python. But yeah, I don't know why I should do that. About the scheduler. As we could see, Dask cares more about, I have a graph, and I want to schedule those tasks in that graph, regardless of how that graph works or that. But in the other way, PySpark has some little of optimizations that's very focused on database operations or data access. But Dask doesn't really care much about that. But also, at the same time, Dask has a fantastic module that I have checked it actually yesterday that's called Optimize. Dask.optimize, where you can import it, and you can give it your graph, and you can really optimize your graph to a way to make things more parallelized. It's just fantastic. Because of the graph, the task graph in Dask, you can have easier way of writing complex algorithms or defining your task workflow, which is in PySpark you are very limited, or even Spark you are kind of limited. You cannot really have the same type of graph or that. PySpark comes with many packages, comes with MLlib, comes with GraphX. You can, there is a really good support. Dask, on the other hand, is being adopted by others. You have scikit-learn, TensorFlow now can read Dask arrays or Dask data frames. You see people are creating this package that's called Dask Learn, so you can use it with scikit-learn, and so on. Okay. I think I talked a little bit quick, and thank you.
Could you give us some examples of cases in which you would prefer Dask over PySpark and the other way around? Maybe
Okay.
because it's easier to write it, or maybe because of speed, or...
Yeah, I mean, it depends on, there are, of course, the obvious answer is it depends, but I can give you several examples. Dask, I would say if I need to run something on a single node, I would use Dask right away. Some people say, you know what, I have to deal with Parquet files. There is no nice Python reader in Parquet files. I will use PySpark. But on the other hand, if it's my choice to choose, for example, which binary format, there is the, I think, H5DF. Yeah, that which is, I think, it's also a great, which is also a great binary format, but it's for Python, which works as good as Parquet. If you are running for small number of nodes, I would go with Dask. So I would say it depends on use case, it depends on the size of the data, and it depends on the resources you have. There is a fantastic paper that's written, I think, by Microsoft. I don't recall when, but I think no one. The paper title. It was, no one got fired for running Hadoop cluster. And it's a famous paper, I think, which means because people are using Spark, that means they are doing the correct decision or the right decision. But that's not necessarily the case. Thank you.
Hey, my other question was like, yeah, since when is Dask, when Dask has been created, and do you have examples of companies or people that turned from Spark to Dask?
From Spark to Dask, not really. I don't have any cases. I know that there is some research lab that is using Dask very heavily. I don't recall the name, but I think it's the one who is the author of X-ray package, if I'm not mistaken. It was created in late 2014. Yeah.
Thanks a lot. How effective is Dask scheduler in case when I have several multi-core nodes, so I can really use all the processor power? C or C++ or Fortran example is like combining MPI with OpenMP, for example. Thanks.
Yeah. Again, here you are very limited with the GEL. So if you are using let's say, if you are using the Dask arrays, you don't have a problem. You will utilize the whole course. If you are using Dask data frames, and if you switch to the multiprocessing, you will use all multi-cores. But is it really faster or not? That depends. But I can tell you the Dask arrays are very powerful, and you will really, if you make the right decisions about your chunks size, you should gain some performance.
Thanks for a great talk. Could you talk a bit about comparing this to Luigi, which you also can use to build interactive graphs of tasks? When would you use each one?
It's really a great question because I can see some overlap between this and Luigi actually. But okay, so Luigi is made to run Spark jobs. It's saying, you know what, I'm gonna when Spotify made Luigi, they wanna run Spark jobs. They wanna run another scheduler, another distributed scheduler to run over multiple nodes. So if you are using Luigi to run Python code, you are running it actually locally in the machine. You're running it on a single node, unless you are, of course, calling it over API or something, or REST API. So, if you are not interested in the intermediate results, I would use Dask. If you are running Python code and you are having inputs and outputs, and you are creating your tasks in classes, I would say, if you are not interested in the intermediate results between the classes, and you are trying to do it to save efficiency or computations, I will try to use Dask. Dask is much simpler. You know, you define your workflow in a dictionary, and that's it. You are good to go.
No more questions? Thank you very much, Eyad. The next talk will be at 3 o'clock, so you will have a break.